So here's some problems from the antiderivative worksheet. I want to give you a few notes here on the power rule. We're kind of reversing the power rule, so you know where we're going on these. And I wrote these up to save a little bit of time, so I'll just kind of expose them as we go along. And this is our standard power rule over here. In other words, if y equals x to the n, then y prime equals n times x to the n minus 1. And remember what we do is we multiply, and then we subtract. So if we're going to go backwards, because that's what we do with antiderivatives, if we start with y equals n times x to the n minus 1, well, we know the antiderivative of this will be this, because the derivative of x to the n is n times x to the n minus 1. But what do we really do? Well, here we multiply and subtract. So if we go opposite, and kind of reverse our direction and negate these things, multiply, subtract, we would add and then divide. So if I had this, if I would, instead of subtracting 1, we would add 1 and then divide by the exponent. Then it's going to kind of undo what we did, and you can see how that works. So I would add and divide by the exponent, by the new exponent, divide by the new exponent. So add 1 to the old exponent and then divide by the new exponent. Just like we multiply by the old exponent and subtract 1 to make the new exponent. And you can see how this works out, so this ends up being the same thing. So if you take the derivative of x to the n, you get n times x to the n minus 1. If you take the antiderivative of this, you get x to the n. So in general, if we have something like this, y equals, or y prime is x to the m, then again we would follow the same order. We would add 1 and then divide by the new exponent. So if I add 1 to the m, I get x to the m plus 1 divided by m plus 1. So that's in general what we do when we're dealing with reversing the power rule to find the antiderivative. Okay, so that being said, let's go on and try some problems. And this is the first one. F of x equals 2x to the third plus x minus 1. So if we add 1, that's going to be x to the fourth divided by 4. So 2x to the fourth divided by 4. Here I add 1, that would just make that 2 divided by 2. So x to the second divided by 2. Here I would add 1. This is like x to the 0. X to the 0 plus 1 is x to the first divided by 1 is just x to the first. And then plus c. And then we can simplify this. 2 over 4 is 2, so we just have x to the fourth over 2 plus x squared over 2 minus x plus c. So that's how you kind of work it out. Let's take a look at number 2. And again, you can always pause these if I'm going kind of fast, since I've already worked them out. Here's number 2. X to the fifth plus 4x plus 1. So again, we'd add 1 to 5, we get 6, and divide by that. So that'd be just x to the 6th divided by 6. Add 1 to x, we get x to the first, would be x squared, and then divide by 2, so 4x squared over 2. And then this becomes x. Remember, the derivative of x is 1 and vice versa, and then plus c. And then we can simplify this. 2 goes into 4 twice, so that's our simplified answer. X to the 6th plus 2x squared plus x plus c. So these are pretty easy once you get the hang of it. Let's try number 3, x to the 5th. So again, I add 1, x to the 6th divided by 6. 2x squared divided by 2 minus x plus c. And then I can just simplify this. So basically that's one thing I can simplify. So this is the same. This 2 over 2 is 1 minus x plus c. All right. And then number 4. 1/2 x to the third plus 6x plus 2. So again, I would add 1 to the 3, so that would be 4. I'd add then divide by the new exponent, so that's going to be x to the fourth divided by 4. And then 6x squared divided by 2, 2x plus c. Now this is just a 2 times 4 in the bottom, so that's going to be 8 in the bottom, so x to the fourth over 8. 2 goes in there 3 times, so 3x squared plus 2x plus c. And again, you can always pause these if this is a little fast. Okay, let's take a look at number 5. And this is what we have over here. Now I know I got the antiderivative of this would be, I would just add 1 x to the 4th over 4, but if I bring this up to the top and make it x to the negative 1, if I add 1 to the negative 1, I get 0, and I can't divide by zeros. So we have to kind of rewrite this. And I think you know, if you look at your flashcards, you got a flashcard that that's the derivative of something. And that's for that one particular case. When x is negative 1, we can't add 1 and then divide by that, because we add 1 to negative 1, we get 0. We can't divide by 0. So this is the situation, one situation where we can't use that anti-power rule, or the power rule reversed. So we have to use the natural log. And we know that the derivative of the natural log of x is 1 over x, so the antiderivative of 1 over x is the natural log of x. So this is going to be x to the 4th over 4, and 4 times the natural log of x plus c. And then number 6. And we don't have anything on our flashcards. I know we have something that's 1 over 2 times the square root of x, but we don't have anything for this, so we have to kind of write this in exponential form. And notice that inside this, if I take inside this, there's just a 1, so I'm not going to have any chain rule issues. Sometimes we do have those, and we'll talk about those later. But otherwise, we could write it like this, and then we can just add 1 and divide. So if I add 1 to 1 half plus 2 halves is 3 halves, and divide by 3 halves, and then plus c. So then we would just invert and multiply. You could also multiply the top and the bottom by 2, and that's going to give you 2 over 3, or invert, multiply. So you have 2/3. In other words, if you're dividing by 3 over 2, it's like multiplying by 2 over 3. And there's my x minus 4 to the 3 halves plus c. And I think that's the answer that we gave you. You could also put this back into exponential form if you wanted, and write it as 2/3, and this would be the square root of x minus 4 to the 3rd power plus c. Okay? So I hope all that helps. And again, like I said, if any of these are fast, just pause it, look at it, and then continue.